So how are we going to filter? Well, we have several tools right in front of us. We have this filter apparatus, sometimes called a filter stage. We have the filters. We have the bottle where the water comes from, and then we have the bottle where the water is going to go. And then we have a pump, because the filters are they have such small holes, you need a little encouragement for the water to go through. And then, very important, we have distilled water to rinse everything to make sure one sample doesn't cross-contaminate the next sample. We take this one and we divide it up to send this off to the lab to get total metals. And we send this one off to the lab after filtering the water to get dissolved metals. But then there's still this one. This goes to the lab with no preservative in it, just kept cold, and the lab measures in this one concentrations of things that require no preservation other than refrigeration. Typically, they measure pH, conductivity, alkalinity, sulfate, and hot acidity. Okay, so we're going to take this water here, which came straight out of the stream. We're going to divide it up into two portions. First of all, we're going to pour some in here for the total, and then we're going to filter some of it using this and put it into this dissolved metals bottle. We're not going to really do it because it takes some work to get these bottles from the lab, and they're all sealed nice, so we're not going to actually do it. If we were going to do it, we would carefully write a lot of things on here so that there would be almost no possibility of getting the sample confused with any other sample. We'd write the date, the name, Friends of Blackwater, the client that's going to supply this to the laboratory. Okay, so what we're going to do is we're going to first open this and pour some into this bottle. And when we go to the lab, we'll say, tell us the concentration in this bottle, and we're going to write that down as total iron, total aluminum, total manganese. And before I said that we want to find dissolved, suspended, and total. So we're going to send this to them as total, and because there's a little bit of acid here, any suspended iron will probably become dissolved iron. What they like to measure is dissolved, because they don't like particles going through their machines that they use to analyze it. Then after we've poured in this sample for total, we'll prepare a sample for dissolved. And again, we will use these filters. These are filters with openings that are 0.4 micrometers in size. And that's a traditional size that's used to distinguish dissolved from suspended. So the first thing, this filter stage in between sampling dates is carefully washed, probably with soap and water, and then rinsed thoroughly many times with tap water and then many times with distilled water, so that we know it's absolutely clean and there will be no cross-contamination. And then the absolutely paranoid chemist would probably rinse it yet again. So that we know none of the dust that's been in the laboratory settling on things contaminates it. So I have a discard pool down here I'm going to pour it into. Ideally, one would have forceps or rubber gloves to handle the filters in case there's anything that would contaminate the sample on my hands. You want to center that carefully. Seal it up again. All right, so the filters come pretty clean from the store, but I like to give them just a little bit of rinse. I don't know if you can see, but there's a little pool of water swirling on top of the filter. So as I said, the pump gives it a little encouragement to go through. We evacuate the bottom so that the atmospheric pressure on the top pulls it right through. Now we're ready to filter our sample. We do want it homogeneous before we pour it through, although there is a risk there that you're going to stir up some particles that are going to clog the filter. I usually give it a tiny rinse with the sample because the drops left over from the distilled water rinse are still in there and will dilute the sample. If we give it a rinse with the actual sample, the dilution won't be so much. Make sure we're washing all the distilled water droplets off the side. And now we're ready to go. If you have a sample that's likely to have a lot of bacteria in it, those bacteria might clog the filter so that you're sitting there pumping, pump, 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 and the water's just going through drip, drip, drip. The ones that filter very easily are often the ones that come right out of the mines that generate the acid mine drainage. There's a lot of reasons why there's no suspended matter in the water that comes directly out of the mines. First of all, it's very acidic, so that a lot of things that would be suspended matter out in a neutral stream are dissolved in the acid. Another reason is that fewer bacteria live in this really acidic water than would live in the neutral water out in the stream. And then one last reason is that the water inside the mine doesn't have a lot of particles in it because the mine is covered. There's nothing falling out of the sky, and the mine's been there for, 50 years or something, so that if the water can stir up anything inside the mine and bring out particles, it probably did that, 40, 30, 20 years ago. So the water that comes straight out of the mine is pretty easy to filter. So the last part of the day is to pack up a set of 3 bottles into the cooler, fill that cooler with a lot of ice, and then sometime soon after, a courier from the laboratory comes to pick up that cooler. In summary, there's a lot to learn about sampling and processing water and being careful. This barely touches it, and a lot of watershed associations, like Friends of Blackwater, have worked really hard to get it right, and they continue to improve as they go.